Welcome to CAD with Mr. Yu. In this video, we'll be looking at part 4 of 4 videos covering the topic Centroids. We aim to become your favorite AutoCAD resource online, and we thank you for joining us in this series of videos covering the topic Centroids. We'll be starting the lecture now. So we're going to trim here. So we're going to go trim there, enter, and I'm going to delete here, okay? All right, so we're gonna drop a perpendicular from here to baseline at where O is located. We're gonna join the point back the end of the line to P, the pole, enter. And as easy as that, this is how you would get the error for this figure, which is called the first right figure. All right, so we're gonna go copy this line, enter. We're going to select P as a base point, and we're going to go up right here, enter, and we're going to trim. So we'll go trim, enter, delete. All right, so we're going to repeat the process. So we keep doing the same process. So we go line to the base point at O, the baseline at O. Then we join it to P, which is represent the pole distance. Enter. And what we're gonna do, we're gonna just keep copying the construction line to fit in the strip that it was generated from. So we're gonna go up right here. And we're gonna trim. So we're gonna trim here and then we delete here. As simple as this. Okay? So we're gonna drop another construction line from this midpoint here at this strip coming down. All right, we're gonna extend this line first, all right? So let me extend this line. So extend this line, get rid of this construction line. All right, we're gonna drop a perpendicular, right? So from here, we're gonna drop a perpendicular coming down. Yes, there it is. And we're gonna go to the pole here, enter, and we're going to copy this line, this construction line, and put it in the strip that it was generated from, which is which is right here. Enter. So we're gonna trim. We're gonna trim this line, enter, and delete the other part. Okay. So we're gonna draw another line again coming down. And we just keep doing the same thing, right? So we're going to go down perpendicular to the baseline at O, going through O. Intersection, we're gonna go back to P. Enter. And we're gonna copy this line going up. Let us see if we can retrace it. All right, so that outer one. So it will be this one. So we go copy this line, enter, base point at P. So we're gonna go up, enter. So we're gonna trim here, enter, delete here. All right, so we're at the last one now. So we're gonna drop a line from here, the intersection. I'm gonna draw it to the base. And then to P, representing the pole. Enter. All right, so which one is it again? Is it all right, so it's this one. We're gonna copy this one. So we go copy base point, enter. We're gonna trim here, enter. All right, what we need now is H, right? So we're gonna H should be right here. It should be right here, right? H. All right, so that is H. So what we would do is the same formula we're gonna be using to get the area for. So what we can do is actually copy the formula. So we go copy. I'm gonna move this first, right? So there, move and carry closer. It should be right here, right? Then we're gonna copy now. Copy the formula. I'm gonna put it. Here and here, right? Enter. So let's step back and see. We're gonna do the same thing to the second derived figure, right? So let's draw it a little bit bigger. All right. So where the center line intersect the object, just as before, we're going to drop a perpendicular and draw it to the baseline at O. So let's go now. So line, this is the center line intersecting there. Let's go again. Line. All right, so let's go now. Line. Intersection. Coming down to the baseline at O. We're going to draw a line to the pole, which is right here. Enter. What we're going to do now, we're going to copy this line right. So we need to copy the outer one. So we'll go copy this one, enter. The base point would be P again, right there, right there. It would be right at the end of the first right figure because we are starting it right here. All right. Let us trim it now. We're doing the same process. So it will be the outer one, I think it is. Right, this is the outer one. All right, so we're gonna trim. Gonna trim right here. Trim, enter, and then delete the other part of the line which we don't. Delete. All right. So we're gonna drop another perpendicular from this center line coming down to the baseline at O. Where's O? Right. I'm gonna join it to P as customary, as performed as stated in the or written in the formula. Enter. Are we gonna trim? We need to copy it first, right? So coming down, need to copy this line. So copy this line, enter, using pole as a base point. Right here. Enter would be the point that we need. And what we're gonna do now, we're gonna trim right above here. So there, enter, and we're gonna delete the other part. All right, good. So we're gonna do the third strip now. So line coming down, perpendicular to the baseline at O, join to P, pull this, the pull, enter. And what we're gonna do, we're gonna do the same. We're gonna copy this line, enter using the pole as a base point displacement. So we're gonna come here, zoom up and there, enter. So what we're gonna do now, we're gonna trim this line, enter. All right, so we're gonna drop another perpendicular from this point going down. So here, going down to the base point at O, there's the intersection. We're joining P right there, enter. So what we're gonna do, we're gonna copy this line right away, base point, right, and we're going to draw the line right at the end of this point, enter. So we're gonna trim, enter. I'm gonna delete the extra part. All right, so we're now at the three strips at the top. So we're gonna repeat the process. So line, intersection, going down to the baseline at O, and then draw that line will be drawn where P is, right here, enter. We're gonna copy this line going up, copy, enter, this line going up right here. So it will be there. Enter. We're gonna trim this point. Enter. Delete. Right. So we're gonna drop another perpendicular here. And we're gonna come down. Perpendicular. Good. And then to the point P. Enter. So let us trace it and see which one is it. It will be the outer one. All right, so we're gonna copy the outer one. Copy this line, enter. We're gonna select the pole So you see how easy it is? It's the same thing we're doing for all three. All right, then we're gonna come right here, enter. We're gonna trim the excess as customary. Gonna trim here, enter, and delete that other part. All right, so we're on the last strip, right? So we're gonna draw a line down from the intersection of the center line for the strip. I'm gonna come down. All right, there it is. I'm gonna draw it to the point P, which is the pole. Enter. So what we're gonna do, we're gonna copy this line now. So let us see which one is it. Good. It's this one. It's this one. So we're gonna copy. Base point displacement is here. And we're gonna draw it right here. Enter. What we're gonna do, we're gonna trim. All right, so we're gonna trim, enter, and then we're gonna delete. Delete. All right, so this distance is h here. This distance is 15. Or h. So this is h. All right, so that is h. So what we'll do now, so remember this is where we are coming from. Then we got the first derived figure, third derived figure. What we're doing, we would find the error for the three of them, and the answer that you would get would be in millimeter square. Now you have to multiply by 2 for each of them. You know why? Because we found the area for half of the object because it was symmetrical. So this would have to be multiplied times 2. Right? So it would be h times 2. Right? Same thing here. Times 2. Same thing here. Times 2. All right, this is 2. That is what the error would be. Okay? So good job if you have gotten to this stage so far. And what we were doing, we were finding having gotten the first derived figure and the second derived figure. What we were doing a while ago was a geometrical construction so that we could get h, right? And then apply it to the formula, right? To get the error for the given question A, this first derived figure and the second derived figure. All right. So here we have the formula for xx to the centroid, which is named y bar right here. And the formula is y bar is equal to the area of the first derived figure times d. D was given a question. Here's a question on the left of the solution, the formula. And the answer would be whatever answer you get would be in millimeter because that would be a vertical height from xx. While the second moment of error about xx would be equal to the area of the second derived figure times d squared, and d squared will be given in the question in millimeter, and the answer would be in millimeter to the fourth, or the same answer would be times 10 to the 6 in millimeters to the fourth power. Then now, the second moment of error about the center of gravity, which is shown here in the question, will be given as the second moment of error, which is the answer that you got up here, right, minus the area of the original figure, which is A, which will be this answer over here, times y bar times 2. So the answer that you got for y bar, you would square it. So it would be, for the second moment of error about the center of gravity, it would be this answer here, which is the second moment of error about xx, right? Minus the area for this figure here, the area for the original figure, times y bar, which is the answer I got over here, squared. And then the answer that you got would be in millimeter to the fourth power, or 10 to the fifth, um, to the millimeter to the fourth power, right? So this will be just be converting it to removing the decimal places, that if you got any a lot of decimal places, right? Like maybe if you got about 0.00 6, for example, this will be bringing to less zeros to the left of the decimal point, right? So this brings us to the end of today's video. In today's video, we looked at centroids. So here's the original question on the left. What we did, we got the first derived figure, then the second derived figure, and then we found the error for the original figure, which was A, then the error for the first derived figure and the error for the second derived figure using graphical integration, right? So graphical integration, the error is equal to the whole distance times h. But because in today's class, the diagram was symmetrical and we only found the error for half of the object, you multiply h times 2. Okay, so that is where the h times 2 comes from, right? And then this is a formula that you would use to calculate the xx to the centroid, which is also called y bar. The second moment of error about xx, and xx would be this baseline here, right? And also the second moment of error about the center of gravity. This will be the formula. So thanks for watching us in this video. Thanks for staying in touch with the channel. And in the next video, we'll be looking at exploded isometric drawing. So looking forward to seeing you in the next video. Please take care until we meet again. Bye. We have come to the end of part 4 of 4 videos covering the topic Centroids. We thank you for joining us, especially those persons who watch the 4 set of videos. And we aim to become your favorite AutoCAD resource online. Please remember to subscribe and like the video, and we look forward to seeing you in the next video covering building drawing. So take care, bye.